Okay. Good afternoon. Welcome to the course Thermodynamics of Materials. Today we are actually into lectures 65, 66. The topic that we will cover today is variation of standard free energy change with temperature. General relationship. General relation. Achha, just put it. No. Actually, Christ. General form would be the right. General form. Let us consider this. This is the topic. Quickly. Recall. Recall, obviously, you have to recall because we actually are taking this class after weeks, several, okay, 1 or 2 months later. So, recall G is H minus Ts. Recall this. Then what is delta G? Is delta H minus delta Ts. Huh? At a given state, the reactants or products at the same temperature. Remember, state, whatever may be the process, isothermal or non-isothermal, adiabatic or non-adiabatic, constant, any. So typically isothermal or non-isothermal, more importantly. So we don't care at a given state, the reactants, this I discussed though already, reactants and products are at, this is at a given underlying given state. So no change at a given state. Okay. So they are at the same temperature. Don't correlate this with the isothermal process. No, any process. Right, I'm writing for you for any process, isothermal or non-isothermal, So that means I can write hence. So delta G is T minus delta H. And under standard states, again at a given state is the standard state, and under standard states, what is this? Delta G0 is delta H0 minus T delta S0. So what is delta S0, delta H0? This you understand. This is actually the enthalpy change of the products and reactants difference, and entropy likewise, and gives energy likewise. So now we start. Now I see one thing I'm writing. Delta G0 is one thing you follow. What I have said. No, delta G0 is always, delta H0 may or may not be function of temperature. May not be function, okay, both delta S0 and delta H0 may or may not be function of temperature. Why? Delta H0, recall delta H0 is not function of temperature. when delta Cp is 0, Kirchhoff's equation, when delta Cp is 0 and delta is 0 is not function of temperature when delta Cp is 0, approximately 0. So, but you note delta H0 is function of temperature when delta Cp is non-zero, and delta H0 is also function of temperature when delta Cp is non-zero, because use the second term, delta H0. This recall Kirchhoff's equation. Recall Kirchhoff's equation. Okay, but interesting. Supposing even when now, so even when delta H0 may or may not be function of it. Okay, so even when delta H0 and delta S0 not function of temperature, delta G0 is always function of temperature. It's always function of temperature. Why? Just keep on writing and noting. See, is always function of temperature. No one can. Why follow this? Suppose delta Cp is 0 and reactant products free heat capacity difference is close to 0 or 0. Then delta H0 is a constant. Likewise, delta S0 is a constant. But there is a T in the expression for delta G0. T is what? T is a function. T is there sitting there. So this makes delta G0 is a function of temperature. T is a function of temperature, if I may humorously say T is a function of temperature. So this is may not be. So this is always, hence always, because of this fact that it is always function of temperature. Just note this, always underline. Hence the importance of this study is always a function of temperature. What is the general form, general relation? This I often write as 3 terms, 5 term relation. It can be reduced to 4, 3, 2. Let us discuss function of temperature. In passing note, this is important to you. In passing note, I already told you, note equilibrium constant is function of temperature only. Equilibrium constant. What is this? K is the equilibrium constant, thermodynamic equilibrium constant. Why? Quickly get this, is function of temperature only, no pressure. You read this last class. K is not a function of temperature. Kx may be Ks, etc., etc. K is never ever by definition. But delta G0, what is that delta G0 is? Okay, minus RT ln K. Supposing a simple relation, A plus BT, this I will give you actually a more elaborate relation, more sophisticated relation, but simplest A plus BT, then as simplest relation, then what you get quickly, this is so important, that's why I am repeating this. RT ln K or ln K is what? A by minus A by RT plus B by R, rather minus, in either case minus. So it is a function of temperature. A is a constant. Remember, A and B are constant. I can give you what are they? Delta G0, H0 and delta minus delta H0 and minus delta 0. But this form is applicable when delta Cp is 0. So and at that time delta H0 and delta S0 is constant. So A plus B are constant, B are constant. So you see, K is a function of temperature. ln K means K also, or K is function of temperature. So this is an important lesson. K is only function of temperature. Delta G0 is also a function of, is always function of temperature and only function of temperature. Why? Only function of temperature. This also and function of temperature alone. Why? Because pressure, standard state pressure is fixed. No scope of variation of pressure. So no chance. Pure substance, standard state. No change of solution, etc. So no chance. So but at the temperature of interest, definition of standard state at the temperature of interest. So function of temperature also. But delta H0 and delta S0, they are also standard state, but they are maybe or may not be depending upon this, because delta Cp relation you actually have to consider this. they are not function of temperature. Okay, but delta G0 is always function of temperature and solely function of temperature, and also equilibrium constant important parameter. We will not discuss this in passing. Our interest focus is today on sometimes you may why equilibrium constant is a function of temperature alone. This is the answers. Good. Next is start to take up this variation of delta G0. I am writing. Okay, I start. Now, next, now, what is this? I'm writing this, some relation I'm writing, D, I recall this relation, del del, del del, del T of delta H at under constant pressure is delta Cp, recall this, recall. This is the, so how where you are getting from where? These are actually all preparatory, recounting. This is what you are getting from our original. Del H by del T under constant pressure is Cp. Remember, this applies for any given substance, say nitrogen, oxygen, iron. But when it is chemical reaction, for a chemical reaction, delta. What I taught you, make delta. Applies for chemical reaction. I am actually variation of delta G0 with temperature. This will actually apply to chemical reactions. Del T del H at constant pressure. Okay, or right, or okay, del T of delta H0 under standard state under constant pressure is delta Cp0 under standard state I am applying. Consider the states are standard state, or d dt simply is delta Cp. Delta Cp0 is a standard state heat capacity, is also actually not, is actually delta Cp itself. Why? Because standard state to non-standard state differs from how? Actually, I said standard to non-standard are purity, since we are considering actually pure substance participating in the reaction, pure condensed phases, gases. So, but another thing, pressure. But Cp is actually not much, not since Cp is not strong function of pressure. So, Cp is since a delta Cp standard to non-standard 1 nanosphere standard, but it is a 5 nanosphere sir, or 1.2 sir. Then since delta Cp means Cp individually, Cp is not a Cp is not a Cp is not is actually also says is not strong function of temperature, function of pressure sorry. Since Cp is okay, actually this is better, not strong function, is insensitive. Is Cp is insensitive to pressure. Over. So this part we have got. Now alongside I am doing something. You follow me. What is delta Cp? You start with delta Cp. I will actually expand on this relation. What is delta Cp? Cp, right? Cp, right? Consider this form. Consider the relation Cp. Consider the CPT relation. Consider the following. Consider the Cp versus T. Consider the CPT relation. What is this? Recall. Tell me. A plus. You have solved many problems. Plus Bt plus C T to the minus T. It can go also another term D etc. But these three already okay covering greater dependence on temperature or covering other all terms other terms. So A plus Bt plus Ct to the minus T. So what is the delta Cp then? Is actually giving the detailed function of temperature. So delta Cp is what? Delta A plus delta Bt plus delta C T to the minus 2. You plus consider this. What is delta Cp, right? Tell me again. Delta means Cp product minus Cp reactant. Cp product minus sigma Cp reactant for chemical reaction. So delta, wherever is delta is product minus reactant. So very good. So just substitute. Now is purely mathematical exercise. Next, remaining part. Okay, these are all about conceptuals or writing or d delta d dt of, oh sorry sir. So if pressure is redundant here, here to here, how, why it is partial to total derivative? Because pressure has no significance here. Standard state means fixed pressure. Pressure constant you don't have to, because pressure cannot vary. So what's the use of making it a constant? So it is, because standard state is a fixed pressure. So it is actually redundant. So remove this and make this total derivative rather than partial derivative. Okay, that's why. And delta Cp0 I have already explained. Cp is insensitive to pressure, so delta Cp. You can write delta Cp0 if you may like, no problem. ddt delta G0 is what? Delta Cp, what I have written here? Tell me. Delta, quickly. This totally math now. Delta A plus delta Bt plus delta C T to the power minus T. Happy? Or d delta H0 is integration. Okay? Integration. Then let me write systematically so that you don't have any trouble. Give a dt on this. Indefinite integration. Okay? Okay. So this is what I am writing term by term. The dt, oh, I have to give integration. I have given integration sign. Delta at, follow me. First term delta at. Second term delta b by 2 t square plus t to the minus 2 minus 1 by t. I think you will get that. Minus delta c by t. Are you sure? Yes, sure. Oh, what I wrote? dt integration means here also integration? No. Yeah, also integration. Or you write delta H0. Delta H0, reference is delta H0 is plus a, you will get an integration constant because independent. So call it delta H old. Don't confuse with delta H0. It's a delta constant. Right nicely. So where delta H is an IC and IC means integration constant. Okay, good boy. So this is you just box this. This is your relationship of delta H0 as a function of temperature. Take a look. This is not our goal is delta G0 versus temperature, but this is okay in okay on the way we got this. Okay, so this is actually delta H0 as function of temperature. In a general relation, you may call it. When all depends upon Cp expression. Okay, 3 terms I have considered. It can be 4 terms even, or it may be a constant only. Okay, by the way, suppose you see what I said here. Can we reconcile with this? Follow. This is a general relation I am saying. But I already said when delta Cp is 0, delta H0 is a constant. It's not function of temperature. Means it's not a constant. Can we reconcile here? It's not a constant. See here. See this statement will follow. And check. When delta Cp is 0, delta Cp is 0 means delta A is 0, delta B is 0, delta C is 0. 0, 0, 0. So only IC means a constant. So the is not function of temperature means constant. Okay, when delta Cp is constant. Yeah. Function of delta H is not function of temperature means constant. Okay, so it is constant. Okay, is fine. Next is what? Next take up delta G0. The next consider Gibbs-Helmholtz equation. Next consider the Gibbs-Helmholtz equation. What is that? In the differential form first. Oh, by the way, this is your Kirchhoff's equation. This is your very one line you have got this. One line got this. This is the Kirchhoff differential form. Integrate your integrated form. What is this? When delta Cp is 0, what does it mean? Delta H is not independent of temperature. Is not dependent on temperature. Independent of temperature. When delta is from this itself. Okay, delta H. So consider the Gibbs-Helmholtz equation. What is this? D recall. D del delta G0 by T, del T is minus good my T square. It is right, correct. This is the I will use this, or or quickly, or acha, what is this? Can I write, since again for the same reason you can write D, okay, D, okay. So constant pressure has no significance here, standard set, d dt, or D, right? I'll just first transpose this, okay, integration both sides like last time, minus delta H0 by, you first write this, otherwise you will be clumsy. The first line, minus delta H0 is dt, very good. Now substitute the expression for delta H from 1, call it 1, equation 1. So is what, write this, minus, you please do this with me, what is the delta H0 expression, write this, delta, 1 by term by term, you follow with me. First term is delta A T divided by T square. What you will get? Delta A by T. First term, delta A by T. Okay. Second term, delta B by 2. This better, I will go up. Huh? Delta B by 2. Okay. And last term, third term is minus delta C by T cube. Take a look. You are dividing by T square only. T cube. Sorry. T cubed. T cubed plus what? Tell me. What is this? H O by T square. Happy? This is integration. Integration. Huh? It's okay. Okay. Achha, just 1 minute. Let me check actually if I have made any mistake. Otherwise, it will be. I think I am correct. Delta by T so minus delta C. Thus, it has not. Let us not take any risk actually. So that now if this correct, this will be correct. Or what is this? Tell me. Integrating. Right. Integrating. I like this. Then I'll take it up. Half. Delta. First delta d0 by t. You write nicely. And do the integration. Like last time. Oh, ho. Tell you what I missed. Tell me. dt. So first term is delta A T ln ln t. Take a look with the negative sign, na? Minus. Okay. Achha. Integration of dt. There is a minus here, na? There he is right. Now what I've done? Oh. Achha, wait. You right. You may be correct. Minus is minus. Why unnecessary? I'm taking this. Why? It's okay. What is delta H0? Term by term. T square minus. Okay, ठीक है. It's okay. So minus delta A T ln T. Okay, I'm very sorry. Ln T. Just ln T. Oh, sorry. Correct. Finally, it will be T ln T. Okay. Minus delta A ln T. But then minus delta B by 2T. Okay. And then last is third is TQ T minus 3 plus 1 means minus our minus 3 by 1 delta C by 2 T square, delta C by 2 T square. Take a look. Minus 3 plus 1 means minus 2 plus 2. There is a minus here. Minus delta. This minus 2 is correct. It is correct. Correct. Take a look. There are so many minus. Okay, one minus here. Integration minus. This minus plus, and that is another minus outside. It's okay. Then what is again? Last one is what? You have divided by t square. Minus. This is very easy. Minus 1 by t means plus. It will be plus. 1 by t plus. And should I add anything? Is I. This time given name I. I is the second integration constant. IC. I is an IC. Okay. So this is your answer. So I'm writing at the tidy up at the top. Remove this. You don't need at all. Yeah. So give a star here. Star. Okay. Or what happens here? or delta G0 is, you tell me one step by step. I'm writing first this term. I'm writing these constant terms. I'm just using this. These last two terms I'm writing first. Delta H O plus IT. Okay, happy? Then you take up next one, minus delta A T ln T. T ln T minus delta B by 2T square. And last is minus delta C by 2T. Minus delta C by 2T. Please put a box and you all set. Just I'll check if we have delta H plus IT is perfect, minus delta T ln T minus delta B by 2T square minus delta C by 2T, perfect. So this is the required relation, right? This is the required delta G 0 versus T relation containing 5 terms. Containing 5 terms. Okay, this is the answer, the question. Okay, very general form. What this is the general form. It can be okay, containing 5 terms. So now corollary or special cases. There was corollary actually. Special cases. You follow this. This is very important. So general is 5 terms. So can I remove this? This maybe I can. It is better I remove this. Maybe this is better. So special case 1. Delta CP is not this. Yes, maintain this. Delta CP. Okay, from 1 I gave. From 1 actually here from 1. Can write this 1 I gave mark. So right here from 1 somewhere. From 1. I'm substituting the value of delta H0 here. Delta H0 have substituted here. Is it? Delta H0 have substituted here. So from 1. So I labeled there. So it is better I use the label. So delta CP. So delta CP is a constant. Special case is a what happens? Is a constant. Is a constant means that is delta CP is only delta A. Is clear? Clear? Take a look. Because these are function of carrying temperature. So these are out. Delta CP is delta. Then what is the delta G0? Then in that case, let's go. C is a constant. Under this condition, delta G0 is this gives delta G0 is what? Tell me, guess. Achha, what is the meaning of this? Implying that is delta B is what? What? 0. Delta C is 0. That's why out. Is it? Okay. So that means what is the relation we get? This gives delta G0 is delta HO plus IT minus delta AT ln T. This is the famous. This is the famous 3-term expression for delta G0. Expression for delta G0 in the form people use this A plus BT plus CT ln T. They write very famous or even write or A plus BT plus CT log T. Sometimes some use ln, some use natural logarithm, common logarithm. Okay, or this. You write, so you give a box here because although is a special case. Second special and very special, very special. Delta CP is not a constant. You can guess what is this? Is neither function of temperature nor a constant. Then what it is? I wrote a few moments ago, 0. Delta CP is 0 is very commonly used by metallurgists or thermodynamists, metallurgical thermodynamicists, often for simplicity. Delta CP is 0. Even though delta CP is, if delta CP is 0, what is the consequence? You quickly tell. If delta CP is 0 means 0, not even a constant, then what are the quick consequence? Now delta H0 is not a function of temperature. Kirchhoff's equation, delta H0 follows it, is not function of temperature. But delta G0 will never, it will still remain function of temperature. I showed you, because delta H0 minus T, there is a T term, and it will be reflected here. So let us see what is delta G0 then. That is delta Cp is 0. Is 0. Actually, it cannot be exactly 0, approximately 0. Practically, essentially 0. Okay, this you have to understand. Yeah, heat capacity is an experimental measure stuff. How can it be ever? But negligible, 0 or negligibly small, to be practical. 0 means essentially 0. Essentially 0. Negligible or essentially. Hence, essentially 0. Heat capacity are experimentally measured. Cell is 0. Okay, happy. So then, giving 0, then what is the delta G0? Tell me. You know very well, easily. Tell me. I can write. That is, right? That is, what is this? In the same way, we write here, delta B is 0, delta C is 0, but this time we write delta A is as well 0. So delta A is 0, delta B is 0, delta C is 0. Very good. And this gives you plus delta H0, subscript 0 plus IT boxes. This is even more famous, even more popular. So this is also, this is the famous, this is also a famous, this is also a famous, this is the famous two-term delta G0 versus T relation. What the people call it? In the same way, delta G0 is A plus BT. That's two terms. The famous two term. Is it two term? 1, 2. This is how many terms? You take a look here. It is how many terms? 5 terms. It's 5. 5 reduced to how many? 3. Still reduced to 2. Still you see, even though all are 0, delta G0 is always function of temperature. Can never be. Okay, it cannot be otherwise. So you are all set. This is your, by the way, now is over almost. Just 1 or 2 lines. Yeah, it is better. I use my fingers. So now this is actually, I tell you what, note delta G0 here also here. Note delta G0 is delta H0 minus T delta 0 always true. All right, is it always true? Left hand side preparatory is always true. Not okay. Always true. Then you compare this. Call it what? Hot equation. Equation what say? Call it 2 say. 2 given name. Equation 2. Compare this. Comparing with quickly. Comparing with equation 2 above. Equation 2 above. Equation 2 above. Okay. What is this delta H0? Please tell me. Is acha I ask you first. What is the delta G0 relation previously? I have removed this. When delta H0 is what? Right. Comparing this, delta H0 is what? Delta H is what? Delta H0. Please. I missed some point, but it's okay. Delta H is delta H0. And what is I? I'm writing for you. Delta G0 minus delta HO by T. Delta HO by T. What it means? Delta G0 minus delta H0 by T. So delta HO is delta H0. What is this? Delta G0 is delta H0 minus H. TS. I'm not writing this. This is so easy. Minus plus is minus T delta is minus delta H0. Please note this. So what is this? I repeat here. So note. What is this in this expression? So note, in equation 2, you just be easy on this. Equation 2, what is delta HO? A constant, integration constant. We call integration constant, sir. What it has turned out to be? Sir, delta H0, our famous delta H0. Okay, in this case, case is case 2, when delta Cp is 0. This case not. Okay, in this case, delta HO is what? Remember, this is a consequence of this. Okay, because you don't get this relation under under this previous condition. You get how many relation? How many terms? 3 terms. It is 2 terms. Remember, so this is always true. So you can compare this with this also, but this is actually a assignment problem, or you have mental work. It's a clever problem. I'll give you that problem. So delta H0 is what? You write once more. See, so important. Delta HO is nothing but, sir, physical significance of this integration constant as if, and I is, sir, once more, right, minus delta H0 box this. Remember, acha, I'm a warning. True when? Tell me. 100% correct. When delta C. True when delta C. Note, warning. Okay. Good boy. Acha, now you may check quickly. I have removed this, unfortunately, but you have retained that. You check whether under this condition of delta Cp is 0, you have a delta H0 expression, general expression. I box this. You check there under the condition of this delta Cp is 0. What is the delta H0 there? What it are coming to? Delta HO. Yes. So makes sense. There also it is okay in compliance with that. No? When delta Cp is 0 means delta A is 0, delta B is 0, delta C is 0. So only delta HO left. So delta must be, and it has been. So this is all about this relationship. I don't think actually, by the way, just I should not waste time. Because this will be actually discussed in the assignment problem. Now should I discuss it with here? Maybe later. Achha, good. Achha, by the way, what is this? Delta Cp is 0. Delta HO is A. If you go by in the form of A plus Bt, what is this? A is what? In the form of A plus Bt, so right here. A is what? Right. Delta HO, and B is what? I. Simply I. Because look, people want to use A, B, etc. A plus Bt. Like A, B. So what is this? Okay, that is A is B. A is delta HO, B is I. So this is, you may write here. A is delta HO, B is. This you may write as well. Okay. When this under this one, true when delta Cp is 0. So over. Okay. Now increase. Actually, it is better I discuss this point. How much time quickly? You answer this question. Delta H0 is 60,000 minus 60,000. Sorry. Minus 60,000 plus, okay, 100T, 50T. The one some example I took, 50T. Example. Application. Given to you. This clearly see. This is actually this data used in the first problem. Okay, what is this called? Sample. What is like said? No, assignment. No, what is this called actually? Okay, some practical problems solved. No, before the assignment, 11 problems I solved. That is sample problems actually. This fine 7 first problem of the metal plus oxygen. Good. Whatever it is, this. Practice problem. I say first practice problem. This is okay. My question, what is, every time I will ask this question, you answer this. Delta H0 is what? How much? Delta H0, clear. This, okay, easy. Minus 60,000 joule. You can give a unit always kilojoule per mole, etc. Kilojoule, 60,000. Quickly. Go easy. But I clear this. And delta H0 minus 50. Minus 50. I didn't there? A plus Bt.
I equal to minus delta S.
This is what? Oh, this is okay so. Minus T delta is 0, delta is minus 50. You just check this, your way. Actually, you can give a per mole, etc. But you must note which mole is per mole. which mole of which species is the per mole concentration. This is very easy. This I will not go back. Answer very easy question I asked you. So remember, it is under which case? It's last case, the simplest. Yeah, delta C is 0. Nothing can be less than this. Nothing is simpler than delta C is 0. You can never. So this is the simplest one you answered. Okay, but this will be used often. And the Ellingham diagram, next topic I will use this. So coming soon. Metallurgists often use for simplicity. See, clearly it is 3 terms. Next it's 1. 2. You answer this. This is for you. Minus 60,000. Again, simple-minded I am writing. Plus 50t plus 2t lnt, for example. This is not so large though. 0.2 t lnt. Again, you have to answer this. Again, what is the question? Question is what? You understand that I am asking a question. I will answer this. Now you think, it is just don't jump into answering. See, you take read the problem first. Joule, kilojoule. Always you use kilojoule per mole. Quickly take a look. See, have changed something. It is how many terms? 3 terms. Is running 3 terms? It's 3 terms. So you basic, okay, what is this called? Fundamental relation you resort to answer this question. What is the delta H? First you give some wrong erroneous answer, then that will be better. Now then you know how you are trapped. What is the delta H? Any clue? Never, at least never answer this. In this case, never. I said this discussion always valid for delta C. Never answer this. Then if you write delta H, delta G0 is delta H0 minus T, delta H0 minus T, then what is this? What is this doing? So this is not the answer. So how will you get the answer? Basic equation, basic, from which you derived everything. If you know delta G0, this you have to convince you that if delta G0 is a function of temperature known, I know delta H0, sir, no one can stop me from knowing. And also, if I know 2 of them, third is always known from this relation as a function of temperature. So never. So only say another one. Delta H0 or delta H0. Suppose delta H0 is what? You take up. What is the relation that I used today's class, and you also studied before today also, and that way I got the answer. That I derived everything. What is how to get delta H0 from delta G0? Now, this is your famous Gibbs Helmholtz that you use today. This you try to follow. This is convincing yourself that if I know this as function of temperature, I know these other 2 guys. So delta, you use this. I will not answer this here. Use del D. Yeah, I think D. Tell me. Oh boy, delta G0 by T by dt is this relation. Perfect. No. Perfect. You can use this. You'll get the answer. And once you know this gives you delta H0 is okay. Acha, you do this yourself. Going back home. Tell me delta H0 will be constant or what? Yes, will be constant. Like this, constant. No, 3 terms. Character is 3 terms. Okay, 3 terms. Or you do yourself, you will get something answer. But you can guess from here what is the delta H0 from that expression that a moment ago you told me. What is that expression? Okay, under what condition is 3 term? Delta Cp is a constant. Is it delta A? So go back there. See, there is a delta H0 expression. Delta H expression. Yes. Is it constant or carrying a constant another term? Delta H0 is what? Delta A is a constant, but delta B is 0, delta C is 0. The expression for delta H0. Delta H naught, and delta H naught is the constant, and delta A is the delta T. Delta is existing, is non-zero. So delta H0 is a function of temperature also in this case. In fact, I told you delta H0 may or may not be function of temperature depending upon delta Cp. This is the case where delta Cp is what? Delta Cp is a constant, non-zero, sir. Not, it's not a function of temperature, but constant, sir. It's not zero. Thank you. So, okay, now how you get delta H0? Use you get what? Use, tell me, delta G0 is always true, delta H0 minus T delta H0, you know the 2, you know the 3, third, okay, as function of temperature, remember, your answer will not be a figure, it is a function of temperature, like delta G, it's okay. So with this we have completed this topic, so I will take up the next one. So it's over, no problem. I've already discussed something that I wanted, but this is a good clue, never know, I will take a problem on that in assignment 7. Sorry, this is better this way. This next is Ellingham diagram. Then how much time? Time. 1 hour. Left. How much? Left.
This is going on.
Oh, thank you so much. So it is a very elaborate topic, but I will actually give the concise form or most important part. Ellingham diagram and its relative stability. Ellingham diagram, relative stability, and is better term here, and relative stability of oxides. And relative stability of oxide. Oxides. Achha. You just follow. Relative stability of oxide. I consider this, okay, the draw a line, this topic. Next topic. It is better I write here, next topic. It is better. Okay, good. The oxidation of pure metals M are written in the following form in Ellingham diagram. Are written in the following form. Based on, right here, 1 mole of oxygen involved. 1 mole of oxygen involved in the oxidation reaction in the Ellingham diagram. You just quickly first finish this in the Ellingham diagram. In the Ellingham diagram, I am writing one by one. Okay, first you write MO2. The oxide is MO2. You keep on M solid. I am solid liquid. I am not writing. M plus O2 is MO2. Which I am writing in the first case. Solid gas, to show that you can always write solid. Okay, MO2 is over. 1 mole oxygen I have involved. You have no difficulty, have you? Any difficulty? No. Achha. Is it a formation reaction also? Formation reaction for which one? Formation applies for to whom? Product. Formed product. So 1 mole. It is also 1 mole. Incidentally, both actually same. Ellingham reaction and formation reaction are same. MO. Take up next MO. I am writing for actually M plus. I am writing. Will you is 2MO? Do you have any objection to this? 2M plus O2, 1 mole oxygen. Since 1 mole oxygen, this is the only way I can write. Okay, good boy. Epithelial formation, what is the reaction? Epithelial formation, note. Contrast rather. Contrast with the formation reaction. Good. Tell me, Deopan.
M plus half O2.
That should be 1. With the formation reaction for MO. What is that? Right? M plus half O2. Good, very good. So since I am discussing, let's complete another thing. Suppose delta G0 is for this reaction is 40, minus 40. Just example, you just try to understand this. Suppose delta G0 formation is minus 40 at a given temperature, etc. etc. What is this value? Delta G0 for the Ellingham reaction. If it is 40, formation, delta G0, formation, so delta standard energy of formation. Delta is minus 40, then what it is? So this you distinguish. I give you, then you have find the formation. So I like this and divide by 2. Okay, so M2O3, M2O3, write yourself, M plus O2 mass, M2O3 right here. And how many O? Since O2 must be 1, it should be 2/3, na? 2/3. M3, and this will be 4/3. No doubt. And last one is, since I'm writing this side, unless okay. Another is M3O4. You recall M is iron. Ap3O4, Ap2O3, M3O4. Tell me what is this? Achha, it is better I write here. M3O4. Quickly. M plus O2 formation. Reaction is metal plus oxygen is metal oxide. So M3O4. What is this? M3O4. Oxygen should be 1, so it should be half M3O4 to make it 2O, O2. This is 3/2. So you all set. Okay. So this can be okay. What alumina Al2O3. This can be okay Fe3O4. Okay. This can be nickel oxide NiO, copper oxide O, etc. So many oxides. Okay. These are MO2 can be silica SiO2. So many. That's it. So with this, now I am going to draw this. Okay. The plotting. Okay. Ellingham diagram. What is Ellingham? Achha, right here. Right on topic. Change this. Delta G0 versus T plot. What is the diagram? Delta G0 versus T. What is Ellingham diagram? Standard energy is plotted against temperature. That reveals the relative stability of oxide and very useful. Okay, but you can always bypass Ellingham diagram. You should. You like. What is this? I'm writing. Draw. No, let us draw. Let us draw. Draw an Ellingham diagram. Let us draw an Ellingham diagram. That is delta G0 versus T for the chosen reaction. For the reaction, 2M plus O2 is 2MO. Yeah, no doubt for the chosen reaction. I'm very sorry. I'm drawing. Can I remove this? This is actually good. I'm drawing this. You be very careful from the very beginning. Sorry, not so much. Delta G0 is plotted against temperature. You can give to practical kilojoule. Temperature is Kelvin. If you are interested, remember this is increasing this way. T of course increasing this way, but these are all negatives actually. I remember somewhere here. Don't worry, this 0 here, typically 0 here. These are all negatives. These are increasing. These are negatives. Okay, right here more negative. More negative is decreasing or increasing. No problem. It's actually negative values. I am drawing this. Please for this. I've drawn this delta G first. What is the relation? Please. What is the delta? Unless you know the relation, how will you draw ever equation are plotted? Delta G0 is, tell me, under the consideration. Another consideration, note another consideration for another important consideration in the Ellingham diagram. Very important consideration, or say consideration in the Ellingham diagram. In the Ellingham dia is that this you must note. Not very important. You know, a moment ago you have actually delta Cp is almost 0. Okay, delta Cp is 0 and is 0. So what is the delta G0 is? I'm writing Delta G0 is since when delta CP is 0, which form it is coming actually? A plus BT I'm writing. I'm removing that delta HO. So that I'm not writing. I, etc. A plus BT. A plus BT. But you know what is this? Always true. Delta H0 minus T delta S0. Do you agree with this? That A plus BT is correct? Of these two, which may be suspected? If we may be doubted. If we may doubt. A plus BT, sir. It is true sometimes. A plus BT is plus CT LNT. Oh, 5 terms. Plus delta H plus 5 terms are you showed. So you are only 2 condensed from, highly condensed. So this is but this is true since delta right here, since delta CP, right? That once more, good thing you can repeat. Delta CP is 0. So this, can we ever doubt this? This is always true, sir. Who is delta H0 minus delta S0? So what is this? Tell me. A plus BT. Okay. So delta H0 is what? Okay. Delta H0. Okay. What is the reaction? Right. The reaction is reaction I've written though. So what is the delta H0 for this? You know what is the delta H0 is? This is what type of reaction? Combination exothermic. This you know, exothermic. But more important is delta S0. So right here. Okay. I'm writing alongside better. Delta exothermic. This is not so important. Okay. Important is delta S0. Slope. Delta S0 is what? Tell me. What is this? Right. 2 delta S0. Acha, right here. 2m solid. Please write. Do write. Acha. No. Okay, here, right here. Is correct. Don't have to write here. Right here. M solid plus 2m solid plus O2 gas. Right here, general M. General M. Plus O2 gas is 2MO solid. This reaction is plotted. Delta G0 of this reaction is plotted. Okay. This is the what, since it's a linear. Right here also what type of relation? Linear relation. So straight line I have drawn. What is the slope? Linear relation. Slope is what? Tell me. Slope of this relation is what? Slope you can write in many ways. A plus BT you can write. Slope is good boy. Minus B. Minus B means actually slope is minus delta S0. No? Slope is A plus BT. Okay. B is what? By the way, here A B is okay. That unnecessary, don't make trouble actually. T is plotted. It is linear. That's enough. Okay. A plus BT. Right. A plus BT. So what is the slope? Slope is what? You write. Versus T is what? Linear relation. Slope is minus delta S0. Please tell me here. Please see, consider 2m solid. Consider now for 2m solid plus O2 gas. Quickly, 2MO solid. What is the delta S0? Please tell me. Why slope should be positive? I'm checking. How should I draw? Delta S0 is what? Delta S0 is what? Write nicely. What is the delta S0? I'll write here. You write. Fundamentally, delta S0 product minus reactant. Product minus. 2 S0 MO minus 2 S0 M plus S0O2 gas. This is solid. This is gas. You right? Solid gas. Do you recall this? Solids and solids actually, solids entropy is much less than gas entropy. Solids. This I said third law, and then subsequently configuration entropy. So to note that, so S0MO, S0M much noting much less than S0O2. S0O2. So what does it mean? What it is then? What it turns out to be? If you neglect this, moreover they are in plus minus. It is small and plus minus, so they actually counter and they actually kind of nullify. So what is this? Is approximately, tell me, S0O2. What is this? S0O2 is a positive thing. Entropy at third law, entropy 0 1 at 0 Kelvin. Then entropy increases. So this is what? Positive. And you said what? Slope is minus. I made a mistake here. Slope is what? We said slope is minus delta S0. ঠিক আছে, very good, very good. Delta is 0, slope is slope is delta 0 versus slope is minus, but what is this? But I'm trying this. Oh, I made a mistake. Algebra, high school. Minus reactant. It is better I write here. Minus, you understand? Shall I write here once more? Right, this is better. Is equals to, okay. So is equals to minus. I think you don't mind. Minus is okay. So now what is the slope? Minus delta is 0. So it is minus delta is slope is minus delta is 0 is plus is 0 to is positive. Slope is positive. So this is the one that I should draw. I have drawn correctly, sir. Positive slope. So means delta is 0 changing, increasing with temperature. So these are negative values. Okay. Now you may check, sir, delta is 0 negative. How you show it? You may ask me, delta H0 is negative. You can check how you get delta H0. Recall high school. How to get delta H0? Y is mx plus c. How to get c? Is value of y when x is 0. So when t is 0, actually 0 can be too much, but okay, extrapolate etc. 0, then it will be to 0, at least mathematically extrapolate. Okay, yeah. Okay, what is this called? Actually, interpolate maybe. Here this value, and these are what? These are what segments? These are what segments? This is value of what is delta H? This is value of delta G0 at t is 0. Y is mx plus c. What is c? Value of y at x is 0. So these are all negatives. I show more and more negative. These are more negative. So this is negative. This is the delta H0 negative. Satisfied. Delta S0 is actually what I wanted to write here. Delta S0 is what? Delta S0 is, I have written here, delta S0 is actually what I have written here is also why suddenly, okay, follow this. Minus delta S0 positive is negative actually. Slope is delta S0 is negative. Don't worry, this part actually you refer to this. Refer to this. Delta is negative, how will you get? Quickly. Delta is 0 what? Product minus reactant. Here, forget all this. What is product? Solid minus solid minus. This solid minus negative. Okay. Delta H0 negative, why? Quick. Which are exothermic reactions, sir? Delta H0 negative, sir. Endothermic delta H0 positive, sir. Reverse is positive. So no doubt is all satisfying. This is the slope. If you may ask me, this is the delta S0. Okay. So this part is clear. This part is clear. Next, suppose we come across a temperature. This temperature when a phase transformation takes place, solid metal melts. What is this called? Melting point of M. Melting point. At melting point, what will happen? What will happen to this value? The slope, where this line will be actually continuous, or it will be actually drift or change the slope. Think about it. Yes, slope to change. Okay, in which direction? This direction greater slope, greater positive or less positive or something like this. Quick answer is here. I'm giving the answer just for clarity. Okay, for clarity. This is the slope has increased. I'm writing this is for which one? Tell me. 2 ml, 2 m liquid plus oxygen gas goes to. This is the melting point, right here. Melting point of metal. Melting point of M. Okay. Now why it has increased? Why it has increased? I follow this increase. Why? Here, what is the slope is minus delta S0. What happens to minus delta S0? Delta S0 first of all, take up delta S0. What is this? What has happened on when it has been liquid? What has happened? This has solid to liquid, which has greater entropy. Small, both are condensed phase, but still it is greater. So minus more means delta S0 increasing. Minus more means minus is increasing, means delta S0 decreasing. What the slope is minus delta S0 is increasing, more positive. Increasing means more positive. Is you are satisfied? So and still another. I think at this position I may remove this. You don't mind? I think this will be better. This is already noted. Unnecessary. This part. Then what you may come across? Further increase of temperature, you will obviously come across the boiling point. Metal boiling point. T, boiling of the metal, right? Boiling point. boiling point of M. M will be gas. M will be gas. So what is this? In the same argument, it will be even greater. It will be even greater. M gas. It is better I write, since actually I have actually a segment here. 2 ml. Let me write nicely. Yeah. 2 ml plus O2 is 2MO solid. This is solid still. This is gas. If it helps you. This will be what? Going to tell me what shall I write? M vapor. Gas means vapor. Vapor or gas? Plus 2M plus O2 plus O2 gas is 2MO solid. Happy? These are the presentation. Okay. Why there is a change? So you see, you will see in your, I brought a, you get a scan copy here. You can see here. You can see here. There are actually, see here. Can I show here? It is better now. I can see it is better now. If I show from this, see this slope has changed. On okay, this has happened. Slope has small. This is small effect because solid liquid small effect entropy, but liquid gas, when there is a gas involvement, greater. I'll give you a copy to you. You'll get a copy from this. Okay, scan copy that I'll give you. I'll give you at the end. Please remember this. I'm sorry that I will give you. This is the answer to this question. Next, acha, you keep this. Acha. Now remove all these things. Remove all these things. Okay. What is that? I'll repeat this part for you. Remove this because I'll redraw this. Just 1 minute. I'm coming. 1 minute. Just check actually. 1 minute. You just relax. 1 minute. I'm drawing a whole stop. Okay. Ellingham dryer for a number of oxides. Number of oxides. I'm drawing this. Oh, sorry, God. For a number of oxides, I'm drawing this. Please follow. I require this diagram that I want to draw. Delta G0. Again, you are increasing this way. This is your zero line. Zero line. This side is positive. This side is negative. More negative. You may, if it helps you, I'm writing kilojoule. I'm writing. Again, I'm repeating. Since you know, I'm showing you one by one. Calcium oxide. CaCaO system. Metal oxide. CaCaO. Then it is magnesium. Sorry, close. I don't have so much space. Magnesium oxide system. Actually, there are actually vaporization. There will change. I'm not showing the simple one. Then you consider. Draw aluminum oxide. Al2O3. Then you consider Ti parallel. Draw parallel. If I could not, but you draw. Oh, more or less parallel or mostly parallel. This is TiO2. This is what then? Al2O3 TiO2. Then it is silica. Silicon silica line. Then what is this? Is chromium. I'm sorry, manganese. I'll give you a MnMnO line. Then what it will be? Chromium. So far, chromium oxide. If you go this way, then the little extend this. There is phase transformation. I have not shown that complication. I have not considered. Then what it is? Say FeFeO iron. Then you consider nickel oxide. copper, copper oxide. You may write another one, silver, silver oxide. Many things, many have accumulator, many have. So why the though it is a little bit okay, not representative, does not is not drawn well, but the lines are the lines. Okay, this okay. The lines are parallel. Why? This is one thing. Why parallel? Achha, what this parallel means? What slope? Parallel is reflected by the slope. These lines should be parallel. These lines are parallel. Why? Why? They look parallel. Look parallel. Why? The what is this? Oxide lines. The metal oxide, metal oxide, metal oxide line, metal oxide lines look parallel. Why? Answer is what is the slope? Slope, you tell me what is the slope, right? Right, slope is S0 metal oxide minus S0 metal minus S0 1 mole O2, 1 mole O2. What is the reaction? What is the reference? 1 mole, always 1 mole. This can be 2, 3, etc. But it is condensed metal oxide minus metal. So right here, metal. I'm not writing. Can I also write here? Why I write this metal oxide MMO? Actually, MO2, MO, etc. So metal oxide is what? Okay, it's okay. Leave it there. So what is this? Is equal to what I said? What I said? Tell me. Tell me. Tell me. Minus S02. These are negligible, small compared to gas. The slopes are means why S02? In each case, one mole O2, because the lines are drawn based on 1 mole O2. What is Ellingham reaction? 1 mole O2, sir. That cannot be changed. 1 mole O2. Okay. So since 1 mole since 1 mole O2 is involved in each line. That is the principle of the reference. How is diagram is effective? Because I am considering a useful reference, 1 mole O2. So what does it mean? So that is, hence slope is same, then that is slope is constant, then all lines have the same slopes. Then all lines have same slope. Namely what is that? Minus S02. What is S02? What is S02? What is S02? Entropy of 1 mole oxygen with negative sign. S02 I have asked. Entropy of 1 mole of oxygen, roughly how much it is? 200 joule. 100 to 200 joule per, okay, entropy has unit joule per Kelvin, remember, per mole, 1 mole have said, per mole, etc. So I am giving a value, practical value. So this is all same, so that's why they look parallel. Okay, this okay. But another important question here, but shall I contrast this, okay, with another one, since actually the lines are not, but contrast this C line, carbon line, this is CCO line, carbon monoxide line, and carbon dioxide line is what, like flat, if I may draw flat straight line, CCO2 line. So note two special cases. So note, okay, note CCO line slope is what? CCO line, tell me, CCO line what slope? What is the other slope? These slopes are what? All lines have the same slope minus, you have said minus S02. Slope is what? Slope is not to that, it is delta S0, boka. Delta S0. And slope is what? Minus delta S0. I see clearly, so positive slope I am drawing. So slope is, and slope is right. Minus delta S0 is plus S0O2 is positive. Is positive. Okay? Is positive always this. So all lines have same slope. I am very sorry. Plus have same slope, namely what? S0 O2. Please check this. Now CCO line have a negative slope. Note, have a negative slope. Has a negative slope. Negative slope. Why, sir? And CCO2 line is horizontal. Means zero slope is horizontal. Horizontal. Why, sir? Zero slope. Why this has happened, sir? Zero means zero slope is zero. Zero slope. Flat line. Okay, so these are all actually, this should be similar. This diagram is not good, but in case I want to convince you, I should have. Here, see clearly, these lines are all almost, you see this, are almost, see, parallel, all. Because of this basis is 1 mole oxygen. Okay, happy? Actually, but this line is coming downwards, I see. This line, take a look. This line is what line? These are parallel positive slope, but this line is CCO line. And what is this line? See, CCO2, almost horizontal. Contrast, okay, you'll get this figure with you. So, but explanation, so why, sir? Why this happens? You can explain yourself. Tell me first, take one by one CCO. First of all, CCO. Take CCO as necessary. This one, keep it here. CCO first. Answer this. Slope only. Concentrate on the slope. Slope is what? Write the reaction first. Otherwise, how will you ever? What is the reaction? Shall I write? Good. Very good. O2, never ever. Okay, 2CO gas. Gas. These are all gas. What is the delta S0? Then you will get slope as minus delta S0. So one by one, sir. Delta S0 what? Write nicely 2S0 CO minus 2S0 carbon solid, you write, minus S0 O2, sir. CO and O2 are gases, and you may consider that gases have similar entropy. You just for the time you consider this. And this is what you write? Solid, what you write? Negligible. Then what it turns? Oh,
Positive.
good boy. Is 2 moles against 1 mole? 2 moles positive, 1 mole negative, having comparable entropy for gases, which may not be true, but comparable. Okay, for our discussion is okay, is positive. If delta is 0 positive, what is the slope? Slope is minus delta is 0. So attack that last. Slope is minus delta is 0 is negative. So no surprise that CCO line has come downwards. Okay. Then next. Okay. So next 1, 2 CCO2 line. This is very important Viva question. 100%, because they ask me why they are parallel first of all, and why this is the opposite slope, and why I was asked also this question. Was very easy, very interesting question, and you welcome this question. So what is the reaction? Yes, I shall write as what? Tell me. Ellingham reaction. This is a flat, sir. O2 gas is CO2 gas. CO2 gas. Again delta S0 first. S0 CO2 minus S0 carbon solid. I am writing, emphasizing on solid. Okay, that's why I am writing. And S0 O2, I don't have to mention. O2 is a gas. Again, you will write that these are negligible, sir.
Rest were cancelling.
Good boy. Because CO2 O2 comparable values. So difference is small or 0. Small, right? Is small. Right? Close to 0. So what is the slope is what? Slope is roughly 0, and no surprise that CO2 is a flat line, horizontal line. So these are the initial discussion. Okay, next I will take up the relative stability. Okay, shall I? What shall I do? I will take consider. Okay, so see, acha, I tell you before I leave. Suppose leave from this circuit. If it is suppose these are parallel, but suppose there is a phase transformation, say vapor, then what will it will be? See that vapor will this will intersect. Okay, once it's actually different inclination, okay, different slope, then they will no longer be parallel and they will be intersecting. So this point is important. I'll consider this now. Remove these are okay. First initial part is over. Quickly, relative stability. This is very important for you. and I hope ah yes, this is relative stability. This is the most important part of this relative stability of oxides. You bring now, you consider, I am considering very interesting thing. A plus, consider these two, consider the following, consider the two, consider given two delta G0 versus T lines. I am giving, I am drawing you for simple discussion, but very useful. Delta G0 versus T. Again, as before, kilojoule, okay, Kelvin. Again, you note this is your where somewhere it is 0. These are all more negative, positive, etc. The zero line. You may draw a friendly zero line just for your reference. These values. Okay, I am drawing two lines. You know, it is A plus O2 is AO2. It is better I write A solid, AO2 solid, sir. One line I have drawn, you have no difficulty, sir. Very good, sir. This is one of them. And another line I am drawing. Another line, okay. Shall I? Actually, it is better I am ready. Okay. First of all, bad. This is now okay. This is better. I made them intersect for some reasons because you may argue this argument I will take myself. Write this A solid, this one, A solid, this one, this line, A solid plus O2 gas is AO2 solid. What is the name of this line? What is this line represents? 2B solid plus O2 gas is 2BO solid. Okay. I consider three temperatures. Okay. It's okay. This line is this. Acha. I consider three temperatures. One is T1. Another maybe TE. Another third. This side T2. Other side of the intersecting point. Okay, T1, T2. Consider T1. Consider the temperature. Temperature T1. We are considering temperature T1. You just consider temperature. The similarly treated other ones. One you understand, all you understand. So, but I assign certain value that will help you. Okay. What is this delta G0? Just assign some value. It is minus 60 kilojoule. 60 kilojoules. Is it minus 60 kilojoule delta G0? What is this value? Will be? Yes. Tell me what this value will be. Towards zero means less negative, means increasing, minus 40. What this value will be? Minus 30. This actually, if I consider this one will be, okay, taking time though, minus 20, and this will be minus 10. Taking time though, minus 10. So you have clear idea. At this temperature, these are the delta G0 values. What is the reaction? It's okay. Shall I? It's okay. What is this point? 60 kilojoule. Okay, good boy. What is the PO2 for? PO2 equilibrium is what I will get. This PO2 equilibrium is what? Is how much? What? How much here for the first case at temperature T1? At temperature T1, temperature T1, at this, okay, when at temperature T1 and when delta G0 is minus 60 kilojoule, means this point, minus 60 kilojoule at temperature T1. At temperature T1, what is the delta G0 for AO2? I'm not writing. What is the for a solid, right? For A solid plus O2 gas. AO2 writing for later I'll write. For AO2 is how much? Tell me. Delta G how much? See the figure. At temperature, what is the value? Anyway, one continuous changes, so minus 60%. Say kilojoule. These all are say. Okay. Then what is the PO2? PO2 equilibrium. What is how you get PO2 equilibrium means ask equilibrium constant. So quick action is what? Delta G0 is minus ln K minus RT means 8.314. What is the temperature T I have considered T1 means some value. Right? ln K is what? Tell me what is the K? The reaction is what? Right here, reaction. A plus O2 is AO2. What is the K? K is what? Tell me. Activity of AO2 by activity of O2 as it should be, equilibrium constant. What is the activity of AO2? These are all pure, solid, pure solid, implied. 1. So 1 by PO2. This activity of the for gas, it is nothing but partial pressure. So it is minus 8.314. T1 is a value that you know. ln PO2 minus is absorbed. Ln PO2. So delta G is how much? I have given minus 60. Okay, kilojoule. Note it is kilojoule. So you will get what? You don't have to consider all these things. PO2 is known. Suppose is 10 to the minus 12 atmosphere. Say, who will calculate? I am not going to calculate this now. 10 to the minus 12 atmosphere. So what I'm writing here, this 10 to the minus 12 atmosphere separately. If you don't, 10 to the minus 12 atmosphere. And here similarly you can calculate. Okay, that will have different delta G0, as you see, minus 40. So you do this and then you will get, suppose it is 10 to the minus 10 atmosphere. With this discussion will start. 10 to the minus 12 like this. This is PO2. So you write here, how we write here? How we write this one? How we write this one? PO2. Sorry. How we write this one? PO2. Actually, this is the style. How we write PO2? AO2. AO2 system. AO2 system. This is the how you actually calculate. Similarly, PO2 you can calculate. PO2 BBO. Exactly similarly. Suppose this has happened to be, is what I consider 10 to minus 10 atmosphere. Say, no problem. This can very easily you can find out. Why you will find that it is will get us, sir? The minus 10, say it is minus 60 means less value. This is now minus 40. Okay, minus 40 means greater value. So PO2 will be actually greater. Okay, otherwise same though. 8 points temperature is same. Otherwise all same. So this increases. This increases. Less negative increases. Okay. So no, there is no trick about this. This is very simple. 10 to minus 10 atmosphere. Now you consider this problem very absorbing discussion comes for 10 to 15 to 20 minutes. Consider the following practical situation. Consider the following experimental situation. You follow with me. I've taken a closed system, constant volume. What I've taken in this? A solid, B solid, AO2 solid, BO solid. How much I have not told you. I've taken BO solid. What is the temperature I have considered? T1. This is right, constant volume. You know constant volume system, you know very well. Closed system, constant volume. Okay. And what is the starting value? PO2 is Initially I filled with 1 atmosphere oxygen. What shall I write here? Initial state. Initial state, you follow this. Very easy, very easy. I have taken some metallurgical sample, pressure, temperature, all known, constant volume. This will go to the final state. They will react, obviously they will react and reach equilibrium state. Equilibrium state. State. You have to find which, you have to, I'm giving a, actually, what is the equilibrium state? Who will be present? Which phase will be present? What is the pressure inside? This is the task. Acha, I help you how to start. You consider this, you remember this, these two never ever forget. Delta G quickly gives. Now you tell me, suppose when you actually have this AO2, suppose you consider a reaction will take place. A is will take place, okay, if it is favorable, delta G is negative, thermodynamically favorable. Suppose A reacts with oxygen forming AO2. AO2 is there, but it does not care. Okay, if it is above equilibrium. First consider A, whether you asking yourself whether A will react under this condition. You have an answer, clear answer. Yes, A will react. Why, sir? Because what is the equilibrium value? Equilibrium value 10 to the minus 12. And what is the actual value? 1. So getter. Remember reaction. Okay, reaction I have written somewhere. Yeah, it is better, right? Similarly, right here. It is better. It is always helps. This A plus O2, AO2 helps. So equilibrium. Always see balance. Equilibrium value is what? 10 to the minus 12. How much I have applied? 1. Greater than 12. 10 to the minus 12. So what will happen? Take place. Delta G will be negative. All the Q less than K, all 1 by Q greater than 1 by Q, whichever you call it, takes place. So how long will it take place? So it takes place and takes place. Then
PO2 becomes equal to
10 to the minus 12. 10 to the minus 12. So that is, so I am writing. So let the reaction sequence. I am writing for you. Reaction sequence. A plus O2 goes to A2, as you said first. Then what is the what? When it will stop? PO2 is 10 to the minus 12. A consume oxygen, reduce the oxygen pressure, form AO2. So PO2 is 10 to the minus 12 atmosphere. It will stop. Now what will happen to B next? Now B will do what? B, what happens to B? See, equilibrium. Take a look at this. This is the reaction. This is the reaction to equilibrium value. Always equilibrium value. Equilibrium constant, or maybe more practically the equilibrium value, which has been extracted from the equilibrium constant. What will happen to this? Take a look. So system is now having what pressure? 10 to the minus 12 atmosphere. It is no more 1 over. So some A has been converted into AO2, sir. B is still unaffected, but will it be unaffected? 10 to the minus 12 is pitted against 10 to the minus 10. Will B oxidize? Ask yourself. B will oxidize? No, his requirement is 10 to the minus 10. It is less than that. He will never oxidize. But rather the converse will happen. BO will be reduced to B. So next is what? Next sequence is BO will be reduced under this condition to B. Reduced to B. Okay. So A2O2. So PO2 will be what it will do? How long? Until it is its value, its equilibrium. Everyone is satisfied when its equilibrium value is achieved. So 10 to the minus 10 atmosphere. Then what will happen to A? What will happen to A? A again asked, what is its equilibrium value? 10 to the minus 12. How much is prevailing? 10. It is greater than 10 to the minus 12, means A will be again oxidized. So A will oxidize. And you will establish again PO2 10 to the minus 12 atmosphere. Then again same thing will happen to BO. BO, no, I cannot allow that. B. So you have understood that this will go on and on and on. Okay. So one thing you see, you follow, then what is happening actually? A is moving towards the AO2 and BO is moving towards B. So what is the reaction actually? So the reaction which is happening, overall reaction may be better term. So the overall reaction, instead of writing this stage, overall reaction which is occurring is what? Tell me. AO2 and BO. So A takes on with BO, producing AO2 and B. Take a look. Am I correct? This is actually taking place. This reaction actually going on inside. A towards AO2 trying and BO towards B. Never. This is all the time happening. Okay. 2B. Thank you so much. So also, so this is a spontaneous process. This is the spontaneous direction. Spontaneous reaction. Spontaneous direction or reaction. This is the spontaneous direction. This is the spontaneous direction or reaction. Reaction. You may get it from thermodynamics first principle. What is the delta? Consider delta G. What is the delta? When a reaction is spontaneous, delta G is negative. So write delta G. What is the delta G here? In this case, delta G is, since all are standard state, these are all pure. What does it mean? Delta G is as good as delta G0. Delta G is as good as delta G0. What is the delta G value? Can you tell me? From this reaction, from the data given, these two data is given. So A plus AO2, A plus AO2, where have it? Minus 60. So it will be nothing but, tell me, A2 AO2 minus 60 and BO2 minus 40. It's okay. Is minus 20 kilojoule. What does it mean? Delta G is what? What? Delta G is what? Negative. Negative. So spontaneous. Hence spontaneous. Hence spontaneous. So it makes sense. Our conclusion is valid. Okay. Conclusion is okay. Good. Sensible. So this is happening. Now question then is but we have not got the answer. So question is this: have you got what is the equilibrium state? If you are asked what is the equilibrium state, then what will be your answer? Equilibrium state. I am giving the answer. I don't have much space here. Equilibrium state here. Equilibrium state is what? Tell me. So it will go on. So you have to specify. This is the equilibrium state. Equilibrium state. This will stay. What will you answer? This way. Equilibrium state is what? Which phases first of all? Which phases? Which pressure I will give you? What is the temperature? Temperature. Tell me. Temperature. It has not changed. Isothermal constant volume. Right. Isothermal constant, not constant pressure, constant volume process. I told you, your thermodynamics can be taken to any system, as a constant volume system, process or system, right? Quickly, take a look. Process or system, as you like. Okay, equilibrium state is what? First of all, tell me which phases will, yes, 5 things were, will 5 things survive? Or who will be present? First of all, you say, sir, these are always produced. So you must write on first option AO2 B, sir. Must. Then of these two, who will survive? Now one which is in greater than stoichiometric amount, which is in state. Suppose it is 1:2, it is more. It is say 1:1. You have taken 1:1. So this is actually more than stoichiometric. So supposing that initially, suppose when right here, no way, here, when A is stoichiometrically, I have to write this, stoichiometrically greater than who? Tell me, who? 2 BO, greater than BO. What is stoichiometry? 1:2. So you have taken 1:1. Means half. Stoichiometry is half. A is to BO, but you have taken 1:1 from the initial. Then who will survive? Who will survive? Who will be left behind? Who will be left behind? Because BO will be consumed. Because when BO will be gone, only 1 will gone. But you have taken, what I said? 1:2. 1:1 I said. But 2:2 you have taken. 2 moles A, 2 moles BO. So 2 moles BO gone means 1 mole of A gone and 1 mole remain. More than stoichiometric. A is more than stoichiometric and BO is less than stoichiometric. So more than stoichiometric, that will survive. That will feature in the equilibrium. So A, this, and BO will be out. So this is the equilibrium state phases first of all. These 3 are no 5, etc. 3. What is the PO2? And PO2 is what? I will be very happy if you apply. I tell you, you cannot answer. AO2. See, AO2 prevail. So AO2 equilibrium value will be exerted. AO2, right? What is that value? Please tell me. Please tell me. Again, P2O2, 10 to the minus 12. So this is the answer, sir. Full description. You will not relent unless you get the full description. This is your understanding of thermodynamics. What you know? Everything you know. What everything? This is possible. See what your answer? Given that A is stoichiometrically excess, in excess amount, stoichiometric excess than BO, greater than BO or in excess, relative to BO. Don't easily accept. You check. So okay, fine. AO2 means now on you gamble. Neither A nor BO2. Because A say okay, it is not again above 10 to minus 12. Neither AO2 will tell you it is below 10 to minus 12. Since it is 10 to minus 12, happy, sir, satisfied. B. You doubt B, whether B is happy. B is content with this value. Will B react against this value? Will B has any objection to this value? Check. When B will object? Any value above 10 to the minus. For B, what is any value when B will oxidize? B means B will oxidize under any value above 10 to the minus 10. It is not. Below, so it will remain very good. So it makes sense in all respects. This. Now, obviously, the opposite is what? 1, 2. Opposite is what? Opposite is what means when BO is in stoichiometric excess. Means what? 1 is to 2 though. 1 is to 2. What is the reaction? 1 is to 2. You can say stoichiometric reaction greater than. That is say 2 is to 2. A is stoichiometric greater than. That is right. I am writing. It helps you. That is A is to BO stoichiometric excess means 2 is to 2. Okay. A is to BO is 3 is to 2. Is even better. 3 is to 2. Okay. Then second is what? Quickly. Suppose I am first answer. What is the answer? If BO is in excess, what will answer? First of all, what will write? The must. Therefore, sir. So let me write, sir. AO2 B. Of these two contending reactants, A and BO, who will survive? Now, which is in excess. So I have considered BO in excess this time. BO in excess stoichiometrically greater. So who will survive? Write that. I write. When BO is stoichiometrically, I am using different language, stoichiometrically in excess. This is the language, proper language. In excess with respect to who? With respect to, tell me who is the BO with respect to A. Like, tell me what is this? Like BO is to A is how much? Suggest me. BO is to 1. BO is to A how much? Stoichiometry excess. What is the stoichiometry? 2 is to 1. 2 is to 1. Excess. BO is excess. So what is that? Tell me. 3 is to 1. Is okay. Happy to. Is it? BO is to A. If you have say cases. Happy? So what is the answer? Then BO will be present in the final state. Have I made it clumsy? Too much clumsy? It's okay. You follow?
We can understand.
You can understand? Okay. Now it's okay. I complete this part, then I will take up next class. It is okay. 3 to 1 to this episode. So we complete. Very interesting. Very. You have not reached actually. See what is this? 3 to 1. It is excess though. 2 to 1 was the exactly stoichiometry. Is 3 to 1 BO will be reporting, not A. So AO2 be must BO. What is the BO2? What is the BO2? Good. 10 to the minus? 10 to the power minus? What you said? 100%. See, here fully described. Like if I ask you what is the temperature, what will be the answer? Oh, sir, it is a constant temperature. Isothermal, sir, T1, sir. T1, sir, namely 900 Kelvin. What is the constant volume is giving pressure, temperature, phases. What else do you want from us? Equilibrium state fully defined and all over. But next question is obviously, sir, if they are in stoichiometric, sir, then they will disappear simultaneously, together, eliminated together. Then what are the phases? Third case can I give? Third case, can I remove this part? Unnecessary is this part? And this part, that will be very good, very good. Third is what? Star. Third. When, what shall I write? Tell me, help me. A and B are in stoichiometry, exactly stoichiometry. When A and third case, 1, 2, 3. When A and BO are in exact stoichiometry. Exact stoichiometry. What is that? What is that? You tell me. A is, tell me. BO is to A is to BO is what? Tell me. Is 1 is to 2. You take 1 mole, you know, say 1 mole iron is 56 grams, sir. BO is nickel oxide, nickel, you know, atomic weight, etc. molecular. So 1 is to 1 is to 2, you have taken. Then what will happen? Who will present? The answer. What are the phases? Equilibrium state. Equilibrium state continued. This is right here, equilibrium stability, equilibrium state. Remember, I have, see here, I have followed this arrow. Equilibrium state I am defining. And this asking equilibrium state is what? Tell me. I will be very happy. Tell me. For A to B must. Equilibrium state A to B, and they will go simultaneously. None of them. What's the Q2? That is the $1 million question. Then if you can answer, then you will be very good. You will be expert. I will be very happy. Very happy. Sir, any value, sir, between these two values, any value, sir. And sir, suppose they are changing, when say pressure is moving 10 to minus 10 to 10 to minus 12, this journey between these, here, at that moment, when it is somewhere in the middle, sir, they are simultaneously moved. So that value may be closer to this, further towards the 10 to the minus 12 side or 10 to the minus 10 side, even 10 to the minus 12 itself or 10 to the minus 10 itself, any value. So what is the right answer? So it can be less than 10 to the minus 10, greater than, right, atmosphere, for complete atmosphere. This is your answer. This is your answer. So, and not only that, equals also will do. Quickly you take the whether, sir, it is okay or not. Check, always check. Suppose I am giving a value between these two is what? 10 to the minus 11. Take a look, ask these two gentlemen, you ask whether they are happy, they are satisfied with this configuration of 10 to the minus 11. Ask each one by one. AO2, are you happy with 10 to the minus 11? Take a look, what is the contention for AO2? What is the equilibrium value? For AO2, equilibrium value 10 minus 12. So 10 to the minus, who is present? AO2 is present. 10 to the minus 11 will do any change to this? Anything? What is value I have considered? Between this 10 minus 11 to, what is present? AO2 is how much? 10 to minus 12. Any value greater than this, but what value I have taken?
Minus 11.
Minus 11. Okay, very good. 10 minus 11, this will oxidize A2. For A2 is what? Or A2 will not oxidize, it will reduce. So any value below, I'm very sorry, any value below 10 to the minus 12 will make any change on A2 by reducing it. A2 to A. Is it happening? A2 will be reduced, will react, means reduce back to A when the pressure is less than 10 minus 12. But it is more than 10. So 10 minus 11, 10 to the minus 11. Example. Ask B whether you are happy, or its equilibrium limit is what? 10 to the minus 10. Any value above will cause oxidation of B. What is the value? Is below that. So B will be very happy. Lower the equilibrium, B will be happy. And oxidation. So these are very good. Okay. If this part is over, that means it will be somewhere between anywhere. So can I get 5 minutes or 10? 5 minutes? 5 minutes on this? I have. I still have. Okay. Now you make a phase rule analysis. Acha, I tell you.
So you can have.
Okay. You just quickly, Billy. Now phase rule interpretation. Then it will be very satisfying. That's why I am taking up. And no point. No one discusses phase rule application in Ellingham diagram. Phase rule, what is it called? Phase rule interpretation. And you will be very satisfied. But phase rule, I will actually give phase rule if I have time. I will discuss. Otherwise, okay, I do not know what will happen. Phase rule interpretation. What is the phase rule? Give phase rule. F is C minus P plus 2. Okay, first two cases. So when how many solids are there? 3 solids. When C is how much? Here C is how much? C is what? What is the system? What is the C? Element wise. Element wise 3 components elements you consider. What are they? A, B, O. O means oxygen is O2, O2 or O. So C is 3. Okay. What is the P? P you consider first 2 cases. P is consider I am writing. You follow me. First 2 cases. You see what is the C? See here. Say this case. What is the number of phases? Sir, solid pure solid means immiscible, no solution. 1, 2, 3, and the gas phase. PO2 gas phase. So 4 phases. Are here also next same. So 4. P is 4. Sir, in either case. Oh, sorry, sir. In either case, one I have written or 2. Nakire. People like here 3 solids, right? 3 solids and 1 gas, which is oxygen. Nakire. It's okay though. This okay. So P is 4. So find the degree of freedom. You'll get some insight. Now quick insight. AP is, you see these observations are in accordance with the Gibbs phase rule. AP is C minus, write once more. What is the C? 3, sir. First 2 cases I am addressing. I'll take up the last one. Then it will be all over for today. 3 minus 4 plus 2. Lucky. 3 minus 4 plus 2. What is this? How many? Is 1. What does it mean? You have 1 freedom. Means 1 you can freely choose. So you have freely chosen what here? I am writing T. What is this? In the form of what you have chosen? T1. T1 is a choice. You could have chosen this one. This one, T1. Say this side, any. You can change means freedom. So you have arbitrarily fixed T1. So it is a freedom, sign of freedom. Freedom is T1 is T1 you have already used up. So no more freedom. No more freedom means all will be settled automatically now. See, you see, are all automatically settled. See, yes, sir. Temperature T1 I have applied. What has the yes, sir, this is the equilibrium state automatically. T1, what is this value? You might say this. Depending on when I write 3 pages, you have to define the system. Okay, AO2, B or BA or